Welcome to Ask and Learn.
So we have 5 capacitors of 100 microfarads each, and we need to somehow combine them to also get 100 microfarads equivalent capacitance and be able to withstand a potential of 90 volts. Whereas each capacitor individually can have a maximum voltage of 50, which is not enough for the 90 volts, so we're going to need to combine them in some way. We can't just use a single capacitor. We want the equivalent capacitance to be the same, but we need to increase the potential difference so they can withstand. So if two possible combinations that we can combine in different ways. One is a series combination. And when we have 2 equivalent capacitors in series, so if these are both 100, then the equivalent capacitance, well, this is 1 over, so it's going to be 1 over 100 plus 1 over 100. So the equivalent capacitance is 50. And if we combine 2 capacitors in parallel, then the equivalent capacitance is going to be 100 plus 100, which is 200. So if we combine 2 capacitors in series, we're going to get half the total capacitance, and if we combine them in parallel, then we get twice the total capacitance. So if we combine these two, if we take a series combination and combine it with a parallel combination, well, the double and the half is going to cancel out. So there are 2 ways we can do this. We can have, if we have 2 capacitors in parallel, then we're going to get half the total capacitance, and if we do this twice, then it will double back up. So if these are all 100, we really get a combined capacitance of 50 on top and 50 on the bottom, which comes out to 100. There's one more way we can combine them, which is if we do this parallel combination and then do it again. So now we have 2 parallel combinations in series, and if these are both 100, now each of these boxes is going to be 200, so they're going to double. But then if we combine the 2 in series, then we take half the total capacitance, so half of 200, we're back to 100 again. So either of these 2 combinations are valid, and we only need 4 out of the 5 capacitors, but it's going to be symmetrical either way. There's no way to do it with 5. And so if we have 90 volts going across from here to here, then either branch of the parallel circuit is still going to be 90 volts. So from here to here is 90 volts. And then now we have a series combination. So the voltage across either one of them is just going to be 45 because we're cutting it in half, and it has to add to 90. So all 4 of the capacitors in this combination are only going to have 45 volts across them, which they can withstand up to 50, so that works. And in the second option, we have 90 volts across the entire combination, so that means we're going to split it in half, so this is 45 and 45. And then for each of these boxes, we have 45 volts, so it's going to be 45 over the top and 45 over the bottom. So in this combination, all the capacitors only have 45 volts across them as well. So no matter which one we choose, we get the same equivalent capacitance of 100 microfarads, and each capacitor only has 45 volts across them, so they can withstand it.